In this video, we're going to use the graph of a function to find limits. Some of the limits we're looking for are going to be one-sided limits, and some are going to be two-sided limits. So here's a graph of y equals g of t, and in part A, we're looking for the limit as t approaches 2 from the left of g of t. So what that means is we want to know what are the y values approaching as the t values get closer and closer to 2, but are all less than 2. So let's look at what the values of t are doing. So we're coming toward 2, but from the left. So we're approaching 2 from the left means all the values are less than 2. And what are the y values approaching when we do that? Well, we can see that we're moving along the curve. If we come along the curve from the left, we're moving along the curve like that. And that means that our y coordinates are going up, and they're approaching the number positive 2. So the left-hand limit, the limit as t approaches 2 from the left of g of t, is 2. All right, let's look at part B. So part B says we're looking for the limit as t approaches 2 from the right of g of t. So as t approaches 2 from the right, that means the t values are all greater than 2, but getting closer and closer to 2. And so we can see along the curve, we're taking on those points there, and that means our y coordinates are coming down and approaching 0. So this limit is 0. Okay, so part C says limit as t approaches 2 of g of t. So that is asking us for the two-sided limit. And that means that we want to know as t approaches 2 from both sides or from either side, what are the y values approaching? Well, in order for that to exist and be a number, both the right side limit and the left-hand limit have to exist, and they have to be the same number. They have to agree. And we can see from part A and part B that the left-hand limit is positive 2 and the right-hand limit is 0. So the left and the right limits do not agree. So that means that the two-sided limit, or the limit as t approaches 2, does not exist. All right, so now in part D, we're asked, well, what is g of 2? And that means, what is the value of the function when t is equal to 2? So we're looking at the graph, and we're looking to see if there's a point on the graph that has t coordinate 2. And we can see there's a hole on one piece of the graph, a hole on the other piece of the graph. So there's no point there, but there is a point right there that is on the graph. So when t is equal to 2, g of t is equal to positive 1. So that's the value of the function g at t equals 2. It's equal to 1. All right. So now in part E, we're looking for a one-sided limit again. We're looking for the limit as t approaches 0 from the left of g of t. So that means our t coordinates, our inputs, are all less than 0, but getting closer to 0. So we're approaching 0 from the left, and we look at what the graph is doing. So we're moving along the graph from the left like that, and we can see that our y coordinates are approaching that number down there. It looks like -1. So that limit is -1. All right, so let's look at the limit as t approaches 0 from the right of g of t. So from the right, so our t values are all greater than 0, but getting closer and closer to 0. And we can look at the curve, and it looks like as we get closer and closer to t equals 0, we're going along the curve like that. And those y coordinates are going down there. And it looks like that number is -2. Even though there's a hole there, it doesn't matter. All the y coordinates are approaching -2. All right, and then the last question is, what is the value of the function at t equals 0? So is there a point on the curve that has a t-coordinate 0? And we look at the curve and we do see a point right there. It has t-coordinate 0 and y-coordinate -1. So g of 0 is -1. All right. In the next video, we're going to look at infinite limits using the graph, and I'll see you there.